Reflection, Part 2. Critical angle and total internal reflection. From glass into air, it bends away from normal. What does that mean? You can see that the incident angle is smaller than the refracted angle, which is in air. The reflected ray bends away from normal. When the incident angle keep on increasing like this, you will see the reflected ray finally travels along the interface, and at that time, the reflected ray suddenly disappears. All the light ray is simply reflected. If you further increase the incident angle, then all the light ray is simply reflected, and there's no refracted ray anymore. So all it starts with, when light ray travels from glass to air, it bends away from normal. When the incident angle keep on increasing, the refracted angle will also keep on increasing and finally becomes 90 degrees. At that time, the refracted ray travels along the interface. We call the incident angle at that time critical angle. You may also notice that the reflected ray becomes very bright, very strong. All the light is reflected, and so we call it total internal reflection. It is indeed not too difficult to find the critical angle of glass. Let me show you how to do this. Let's take a look of the diagram in the middle. By Snell's law, we may set up the equation. The refractive index of glass equals sine the angle in air over sine the angle in glass. And so we may have this result. And you are going to do the experiment yourself to determine the critical angle of the semicircular block. And in this way, you may calculate the refractive index of the semicircular block. For question 45, you are going to find the critical angle. You may apply the equation eta equals 1 over sine c, so that sine c equals 1 over eta. In this way, you can find the critical angle C easily. Let's move on to the second part. Applications of total internal reflection. Here, we are going to discuss 4 applications of total internal reflection. 1. Light sky. Light travels by successive total internal reflection inside a light guide, so that it may be used for illumination or data transmission, such as optical fiber. When light carrying signal travels through optical fiber by successive total internal reflections. When compared with copper wire for signal transmission, optical fiber is cheaper and lighter because different colors may pass through a single optical fiber at the same time. So optical fiber may transmit more data than a much thicker copper cable. And that explains why phone calls are so cheap and why internet is basically free. The second application is a periscope. You may make a periscope by using 2 parallel mirrors, such as the diagram on the left-hand side, so that light may pass through the periscope by 2 reflections. However, mirror forms multiple images. The images are not clear. We say the quality of image is low. On the other hand, by using prism, then total internal reflection will produce high quality image, which is sharp and bright. However, periscope produced by using prism will be a bit heavier, and of course it is more expensive. The next application is called Mirage and Newman. The YouTube video below shows you some sense of Mirage and Newman. So on one side of a desert, you may see something just like this, which looks like a pool of water, but actually it is not. It is mirage. Mirage is formed when there is a high temperature gradient in the atmosphere. What does that mean? That means there are different layers of air, and then they have very different temperature. So the professor say his left hand can feel the air is warm, while his right hand can feel the air is cool. When the light travels across different layers, light is refracted and it bends away from normal. It doesn't only bends away, but it even reflects outward, just like total internal reflection. So the light from the top of the hill will just go down and to be reflected, so you see the hill on the ground. So it's just like there is a pool of water that reflects the light of the hill. Well, mirage is the name given to what happened when there's warm air on the ground and cool air above, which is what happened in desert. Newman is the name given to something just opposite, when the air near the ground or the sea is cooler, and this happens in places which are very cold, near the poles. The last application is called rainbow. Rainbow is produced by dispersion and total internal reflection of light. When sunlight from behind the observer goes into a rain droplet, the rain droplet disperses the light that splits the light into different colors and also reflect them by total internal reflection. When we stand still, different droplets will reflect different colors of light to our eyes, and so different colors appears at different angles, and that produce a rainbow like a semicircle. If you have a strong laser pointer at home, you may try these experiments, but beware not to direct the laser pointer to anyone's eye. It is too powerful.